Hello everyone, and welcome to the first part in this series of videos exploring qualitative coding. My name is Amir Mikhailovich, and I'm a consultant for UBC Library Research Commons on computer-assisted qualitative data analysis, otherwise known as CACDAS. In this video, we will explore coding in computer-assisted qualitative data analysis. I will demonstrate some of the ideas in NVivo for PC, which is a CACDAS package that UBC currently makes available for free for students, faculty, and staff. All of the concepts and processes that we will cover in these videos apply not only to NVivo, but to many other CACDAS packages such as Atlas TI, MaxQDA, and many others. For an overview of different CACDAS packages, see the link in the comments section to the UK-based CACDAS networking project. Our objectives for this video are to explore definitions of coding in qualitative data analysis, or QDA. What do we mean by coding in QDA, and what are we doing it for? We will then explore the notion of coding cycles, consider common types of codes, including data-driven and concept-driven codes, and lastly, we will review common coding tasks, which I will demonstrate in NVivo. Let's begin with a simple question. What is coding in qualitative data analysis? Many scholars have addressed this question in different ways. Bogdan and Bicklin, in their widely referenced book Qualitative Research for Education, defined coding as a means of sorting the descriptive data you have collected so that the material bearing on a given topic can be physically separated from other data. Similarly, Richards, in her book Handling Qualitative Data, likened the coding process to filing techniques, by which we sort everyday information and ensure access to everything about a topic. But coding is not only a matter of separating, sorting, and filing data. Corbin and Strauss, in writing about the qualitative methodological approach grounded theory, defined a code as an abstract representation of an object or phenomenon. Indeed, some codes will be more abstract or conceptual than others. We will revisit that idea. Lastly, Saldana, in his well-known book, which is all about qualitative coding, The Coding Manual for Qualitative Researchers, defined a code as most often a word or a short phrase that imparts meaning to a portion of data, be it in language, image, video, or audio. Importantly, Saldana noted that the meaning that the code imparts to that portion of data can act as a summary of that portion of data. It can capture something salient or evocative about it, or attempt to capture something essential about it. A really useful point that Bouyatsis made in his book about the qualitative method thematic analysis highlights that coding goes beyond sorting, filing, and labeling. It is a way of seeing. When we review qualitative data, we sense patterns or occurrences, what he calls seeing. But then encoding those patterns, classifying, or describing them is seeing as. Through seeing as, or coding, we link new or emergent patterns with patterns that we observed and considered previously. Saldana made a good point that coding is often done in cycles. He distinguished between first cycle coding, when codes are initially assigned to data segments, and second cycle coding, when codes are developed further from first cycle codes. For example, during first cycle coding, we can code descriptively using nouns or short phrases such as stability or security as labels for our codes that summarize the topics of data segments. Or we can do process coding when we use a gerund as a label of a code to connote observable action in a segment of data, for example, managing behavior, lining up for lunch. In second cycle coding, Saldana argued that more categorical, thematic, conceptual, or theoretical organization is developed from those initial first cycle codes. For example, what he calls pattern codes pull together data segments from first cycle codes into fewer, more meaningful, and more condensed analytical concepts, relationships, themes, or constructs. Saldana's distinction seems particularly useful for bottom-up or inductive approaches to coding that are driven by data rather than by theory, in which case the approach would be top-down or deductive. Different from deductive approaches, inductive approaches necessitate primarily descriptive first coding cycles before moving to second, more conceptual coding cycles. Another distinction has been suggested by Maxwell and Schmiel, which is applicable for both inductive and deductive approaches. Maxwell and Schmiel distinguish between organizational, substantive, and theoretical coding categories. Organizational categories are like abstract bins for sorting data for further analysis. They don't specifically address what is actually going on in the data or what meanings this has for participants. These organizational tools can be used to store things that we already know about the data, such as respondents in a survey and their education level, or topics such as policy or goals. These codes involve relatively little interpretation. Substantive categories are fairly descriptive in that they stay close to the data without implying a more abstract concept or theory. They may involve descriptions of participants' concepts and beliefs, or what they are doing in more descriptive terms. These are categories that generally you would not know in advance would be significant, unless you were already quite familiar with the data. They are often emic, which means that they are taken from participants' words and concepts, but they can also be etic, which means that they are based on the researcher's understanding of what is going on. In both cases, the implicit claim involved in these substantive categories could be wrong. They are different in that way from organizational categories. They're like containers for holding data. Lastly, theoretical codes situate the data in a theoretical or conceptual framework, using categories or labels related to that framework. In methodological approaches such as grounded theory, these theoretical codes will likely be derived from the study itself rather than previous literature. They are usually etic, representing the researcher's concepts rather than the participants' concepts. Although Maxwell and Schmiel described an inductive progression from substantive to theoretical codes, it is also possible to imagine a deductive progression from theoretical codes to substantive codes that, well, substantiate the theory, or suggest how it might be modified. So now that we know what coding in qualitative analysis is and what form it might take, let's look at some common tasks associated with coding. For this slide, I will use NVivo to demonstrate some of the ideas. First, as we create a new code, we are required to provide a label. This is where we can put in the noun or noun phrase or gerund that we had in mind, among other possibilities for labeling codes. But as our analysis evolves, we might want to relabel the codes. In NVivo for PC, this entails right-clicking on the code from the code list and choosing Code Properties. In the box right next to Name, we can change the label. This is a good place to mention another common task associated with coding, which is to define and redefine codes. In that initial moment when we created the code, you might have noticed that we had an option in NVivo to provide a description. This space is great for fleshing out and writing what you think belongs to this code, a summary or definition of what this code includes as a collection of data segments. Make sure to also provide an example. Trust me when I say you might not remember any of that when you return to the project after a while, so make sure to write the definition down, including an example or two, as soon as you can. A really interesting process that is associated with coding is the splitting and merging of codes. Some people, in some situations, when they review an interview transcript, might create many codes that each have few data segments associated with them. Although these folks, who are often called splitters in the literature, will remain very close to the data. Their code lists will be difficult to manage. Splitters need to work on merging their codes, finding ways to condense their code list, not necessarily at a more conceptual level yet, but just to make their analysis more manageable. For example, in the NVivo sample project of a survey of high school alumni, we can collect these codes that we see here that also happen to have few data segments associated with them under a new code called Criticisms of the High School. NVivo allows us to tuck these codes underneath the new parent code, which is great for keeping the highly split level in case we need it, but also to move into a more manageable code list. In fact, we can decide to include all of the data segments associated with those now children codes, types of criticisms, with the parent code, Criticisms of the High School. We can also disable this later on if we want to. This replaces the need to permanently merge those children codes into the parent code. This is great because seldom are we so sure whether an action in qualitative analysis should be permanent. So far we discussed splitting, or splitters. What about lumpers? Lumpers would be those who prefer fairly short code lists, but each code is, well, a big code with many segments of data associated with it. Since in qualitative analysis we are interested not only in what might be prevalent, but also in how it is prevalent, just having a list of codes that show prevalence of patterns may not be enough. Lumpers may want to delve into their so-called monster codes and see if they can split according to dimensions or sub-patterns. In NVivo, this would mean reviewing the content of a given large code, coding data segments to new codes, for example, in this case, harsh teachers, and then uncoding from the parent code, in this case, criticisms of the high school. If we have created the code harsh teachers, we might want to make sure that the code is placed underneath criticisms of the high school. This example helped us see the tasks of splitting and merging, or rather aggregating, but also moving codes around in the different hierarchies that we created in the software. Interestingly, in inductive approaches, what Raymond Gibbs called data-driven approaches, detailed coding or splitting may be prevalent in the first stages or cycles of coding, but then followed by a lumping process. Differently, in deductive approaches, which Raymond Gibbs called concept-driven, broad brush coding or lumping might be prevalent in the first stages as we seek to lump together things that are associated with theoretical codes. But we might later split those broad brush codes into subcodes to see more nuanced meaning that might inform the theory we employed. That's all for this first video. In the next video, part 2, we will explore categorization and code hierarchies in computer-assisted qualitative data analysis. See you there.